Hi, my name is Sundus and this is my absorption and lime causal concentration presentation. So first things first is the purpose of the experiment. So this experiment helps to investigate how compounds absorb visible light, and this helps us establish a connection between the absorbance and the concentration. And this helps explain why objects appear colored to the human eye. And these have its practical and educational advantages, which we are going to discuss on the next slide. So they have numerous uses in our daily life. For example, the quality control of food and beverages. Another thing is the detection of contaminants in water, and even in medical diagnostics. An example being is the identification of the quantity of chemicals in blood and urine. This is important because knowing how light interacts with matter enables consistency, quality, and safety of numerous processes and goods in our environment. Next, what we are going to discuss is the method. So we calibrated using deionized water in a cuvette. We were given 7 different ink solutions and a standard lime solution cordials of 20%, 40%, 60%, and 80% were prepared via dilution with water, along with an undiluted cordial, and that absorbance was measured. The absorbance of the unknown lime cordial was measured 3 times. This actually helps improve the experiment by making it more reliable, because errors are normal to occur. So repetition actually helps consistent results. Maximum absorbent values were recorded and used to construct a calibration curve. And using a calibration curve, this actually helps us identify unknown solutions concentration through the lines made. And these measurements were all performed at room temperature. So here is a graph of our results, and on the next slide we are going to discuss them. So here, the absorbance spectra obtained for the lime cordial ranged between 400 to 550 nanometers, which is over here, and these are specifically the blue and the green parts. And within those parts there is a lot of absorption over here, and we know that because there are a lot of peaks occurring in these 2 areas of the green and the blue parts. However, if we look at roughly between 430 to 460 nanometers, you can see that there's a peak roughly here, and that peak is specifically a characteristic from a synthetic food dye called tartazine, and that's commonly used in lime flavored beverages. However, overall we can overall, with increase in lime concentration, the absorbance does increase proportionally, and this actually supports the Beer-Lambert's law. If we go along the line and we're just somewhere around here, which is actually 600 nanometers, the absorbance does start to diminish. And what this does say is that there are minor variations between replicates, which could be attributed to differences in dilution accuracy, as you can see over here in these parts. Overall, the results demonstrate that the coloration of lime cordial is strongly dependent on the dye, and that spectrophotometry is an effective method for quantifying color intensity in beverage analysis. Overall, what we can say from this experiment is that visible spectroscopy demonstrated that absorbance is dependent on both wavelength and concentration, making it possible to determine the concentration of an unknown solution. And these are the references that I've used in my presentation. Thank you very much for listening and viewing it.